This video is going to explore how our brain responds to threat and danger, and how the arousal response can get activated. I like to think about these brain structures as parts that have their own ways of acting and responding. I hope this makes sense to you too. I'm borrowing from Dr. Bruce Perry's Neurosequential Model to illustrate the brain. This model illustrates the sequence of going from lower levels of brain area, which tend to be more primitive and simple in their processing ability, to higher levels, which are more integrated and complex. Starting first with the lower brain areas, the brainstem is really important because it's focused on basic functions of survival like breathing and heart rate and blood pressure, so the things that keep us alive. The next level up is the diencephalon. The processes here are still more primitive, but they are getting a bit more complex. They reflect more coordination and regulation. This level of the brain focuses on various bodily states, for instance, our state of arousal, our circadian rhythm, and our hormones. It's also the level that processes sensory information and connects it to higher level brain areas. The limbic system is the area where emotions are processed, where certain memories are processed, and where our reward system is. These areas of the brain are still a little bit more basic in operation, and they tend to be underneath our conscious awareness, and processing is happening without our understanding. Lastly, we move into a more complex system, the cortex. This is where we start to see the behaviors and processing that really set us apart as humans. It becomes more abstract. These are processes like thinking, having values, using symbolic representation like language and time. All of these areas are important when we start to think about how stress and trauma are processed. And within these areas, there are particular brain structures involved. So let's look at this cast of characters. The first thing that happens is that sensory information comes into our brain through the brainstem. This is what helps us make sense of the world, especially as it relates to survival. After coming in through the brainstem, the sensory information is processed by a structure called the thalamus. We can think of the thalamus like a relay station, receiving incoming information and then sending it to other higher level areas of the brain for further processing and integration. The hypothalamus is also an important player when we think about processing stress and trauma. One of its many functions is to initiate an arousal response when our sympathetic nervous system is activated. The hypothalamus sends chemical information to other key areas in what is known as the HPA axis: hypothalamus, pituitary, and adrenal gland. The amygdala, which is really the star of the show, is the threat detector. It's like a first responder when it comes to danger. The amygdala is where threat is recognized and also stored as memory. This type of memory is implicit, meaning it's not in our conscious awareness. It's fragments of sensory information and emotion, the type of data that is processed by the lower brain areas. Another important brain structure is the hippocampus. This area is also involved in memory, but it's explicit or declarative, meaning we can speak about it. It's within our conscious awareness. This type of memory is categorized as semantic or episodic. Semantic memory reflects our memory for facts and information. Like if I ask your birthday or your phone number. If I asked you what you had for dinner last night, that reflects episodic memory. Those are the stories of our life, the narrative. They're called episodes. The hippocampus is also involved in our sense of space, where we are, but it doesn't have a sense of time, which is a higher level function. Enter the cortex, or specifically the frontal area called the prefrontal cortex. This area is involved in regulation and thinking and planning and decision-making, processes that really set us apart from other animal species. So here's the cast of characters, and we'll see how they all play a role in how threat and danger are processed in our brain. The thalamus is one of the first structures to receive incoming sensory information. Once it does, it sends it to other brain areas for further processing. One of the areas it might communicate with is the amygdala. If the incoming information is alarming, then the thalamus alerts the amygdala, whose job it is to look for danger, both real and perceived. I want to stop on this point for just a second, because I think it's important to note that the danger can be real or perceived. Actually, both will activate a stress response. The point is that this response reflects what is happening now. The amygdala is looking for incoming sensations that signal threat or danger in the environment. But the amygdala also has this whole catalog of past experiences and emotions and events that it's checking this new information against. These are often called evocative cues. When these sensations are coming in, these evocative cues, the sights and smells and sounds, are being checked against what's already in this catalog, or in this picture, the wagon. Our wagon includes what we've known to be true in the past. And if it's alarming, then the amygdala is going to respond. And I want to remind you that the amygdala's catalog of memories are implicit, meaning below our conscious awareness. So it's cataloging against feelings and sensory fragments that you can't even put words to. So the amygdala is alarmed, but it can get input from some other brain areas. It can check in with the hippocampus, which can offer memory and context. The addition of context is really helpful in allowing us to make sense of what's going on. The other brain area that can be important is the prefrontal cortex, because not only can the prefrontal cortex actually shut the stress response down and provide some regulation, it can help with higher level thinking and planning if the stress response is warranted. Okay, well, there is a problem, so we need to split. So let's run out the back door. Unfortunately, we don't always have access to these higher level thinking areas. When you experience threat and danger, often these areas sort of go offline, and we end up creating a strong pattern of response that primarily involves the lower brain areas. So the hypothalamus will get involved if we haven't had this input from the higher levels. And again, the hypothalamus is involved in the arousal response. It's part of the HPA axis, and it will initiate our stress reaction. So if the amygdala is not listening to the hippocampus and the prefrontal cortex, these higher level areas, ignoring what they're saying, but instead sending the signal to the hypothalamus that this is danger, this is danger, this is danger, that pattern actually becomes pretty well formed. And so when you start to think about people that have had a lot of trauma in their life and have been under a great deal of threat and danger, that pattern or pathway is very well formed and tends to be a bit of a superhighway. And so the input from the higher brain areas become less effective and quieter. And the stress response is going to be initiated faster because that person is more sensitive to the incoming sensory information. So if our threat or arousal response is activated, what might we do? How would we respond?
Our fight or flight system, as we commonly refer to it, is associated with a number of reactions, ranging from freeze, flight, fright, and fright, among others. Tune into part 2 of this video series to learn about how stress and trauma impact our behavior and how we respond.